So in this video we're going to be looking at question 3 of the 2012 SACE Specialist Mathematics examination. So question 3 is looking at a circle theorem, deductive proof question, deductive geometry, and we're given a figure. And in figure 2 we have points A, B and C lying on the minor arc here of the circle, with a centre O, and we're given the centre O. As you can see, I've already drawn a few things on here which come in handy later. We'll come back to them at the moment. But in the original question, the 2 beta was not given, neither was the 2 pi take 2 beta, or the right angles. The tangents to the circle at A and C meet at a point T, which is all the way out here. And we know that angle ABC is equal to beta. So now the first part of this question, which is worth 3 marks, is to prove that angle ATC equals 2 beta take pi. So first off, we can work out the external angle of AOC, so this angle here, the 2 beta of AOC, it's the external one. And we can do this using the angle at the centre rule, because what we're given is we're given this angle beta here is ABC. But if we look here, we know this is point O, the centre of the circle. And based on angle to the centre theorem, we know that that there is going to be 2 beta, because it's at the centre to that angle there. And we know it's always twice as much. So that's a little bit tricky. It's not immediately obvious that you can use the angle at the centre theorem there. But once you've fastened onto that idea, the rest is fairly elementary to go through the rest. So that's probably the hardest part. So now we can work out the internal angle of AOC, and internally it's this angle here, which is the 2 pi take 2 beta. And we do that by using angles at a point. So we have 2 pi take 2 beta, because we've got 2 pi radians in an entire revolution, and we take off the 2 beta that we have there. So now we've worked out those angles, but the next key thing we need to do is start looking at how we can start moving towards drawing some conclusions with this angle up here. And so we're given the centre for a reason. We know that OA equals OC equals the radius of the circle. So consequently, we know that the angle TAO and OTC, which are these angles here, are going to be 90 degrees based on the radius tangent theorem. And as a consequence of that, we can start constructing the following equations. Because they are equal, we know that the opposite angles are equal, because these two angles are opposite one another. And what we can actually say now is that this ATCO, this little quadrilateral here, is actually a cyclic quadrilateral. And as a consequence, we know that opposite angles of a cyclic quadrilateral are complementary. So we know that these two are equal, and because they're 90 degrees, they're supplementary, because 90 plus 90 equals 180, or pi on 2 plus pi on 2 is 180. But we can use this logic because we know this, and we've just proven that this is a cyclic quad, in order to actually get the angle ATC, which is what we're after with our solution, because we know the opposite angle here. So, because they're supplementary, angle ATC is pi take angle AOC internally. It's equal to, hence, because of that, pi take 2 pi plus 2 beta. And what we end up with when we simplify this expression is 2 beta take pi, which is what we were asked to find. So we've effectively proven that angle ATC is equal to 2 beta take pi, just using some circle geometry there. So the next question is pretty straightforward. Prove that the quadrilateral ATCO is cyclic, and as demonstrated in A using the radius tangent theorem, we saw that there was a cyclic quadrilateral because these two opposite angles here were in this case the same, but in general we need them to be supplementary. It just so happens that when they're 90 degrees, they're both the same and supplementary, but because they're supplementary, that's the conclusion we need to use for the ATCO cyclic quad. We're able to draw that conclusion. Okay, so now the next part is to consider the quadrilateral ABCO. And what we need to do is find out for what values of beta is ABCO a parallelogram, and give reasons. Well, we know for a parallelogram the opposite angles are going to be equal. So consequently, from our original diagram, which we looked at in part 1, we know that 2 pi take 2 beta must be equal to beta because those opposite angles are the same, and we're trying to prove that this particular shape here is a parallelogram. We'll find the value of beta which will make it a parallelogram. So by equating those expressions and solving for beta, we find that beta is 2 pi on 3, which is consequently 120 degrees. So the very last part of this question asks us to prove that AC and OB are perpendicular for the value of beta you found in the previous part. Well, we know that AC bisects BCO and BAO. We know it's going to bisect because they're diagonals. So the angles of a quadrilateral, we know, add up to 360 degrees, and hence the angle BAO plus BCO is going to be 360 take 240, because those are the two angles that we don't know yet, and we know that the other two are 120. So using this logic and using simply as I said before, that the angles of a quadrilateral is 360 degrees, we know that the sum of those two angles is 120, and hence each angle must be 60, because they have to be equal in a parallelogram. So in considering the triangle BAP, where P is the midpoint where the two lines intersect, two diagonals meet, we can actually solve for the value of BPA, which is the angle there, which we need to be 90 degrees in order for us to conclude that diagonals are perpendicular. So angle BAC is hence going to be 30 because we have that bisection of the diagonal, and we know that the bigger angle is going to be 60 degrees. And from there we also have 60 degrees here as being the other one that is bisected. And by taking their sum, we know that they must equal 180 because the angles in a triangle will always add up to 180, or pi radians. And what we're left with is the conclusion that angle BPA equals 90 degrees. From this, we conclude that AC and OB must be perpendicular because there is a 90-degree angle between them. So thanks for watching this video. Hopefully it wasn't too hard to follow along with. But yeah, it's question 3 from the 2012 SACE examination paper.